Welcome to White Industries VR Tour. Established in 1960 in Dalby, southeast Queensland as a jobbing repair shop, it has grown into the foundry and CNC machinists we are today, producing castings for a wide range of industries such as mining, rail, general engineering, automotive, road transport and agriculture. Let's head inside. The first step in the casting process is making permanent tooling. A pattern is a reusable tool used to create single-use sand moulds, which are destroyed each time a casting is poured. The pattern creates the external shape of the part to be cast. A core box makes the internal detail if the part is hollow. The tooling can be made of timber, resin or metal, depending on the number of castings to be made. Permanent tooling has been known to last for decades. Core making. Any parts that have hollows will have a sand core made. Cores can be hand-packed for small quantities, or they can be blown on one of the two modern core machines at White Industries for larger quantities. Machine-made cores are most cost-effective as the cycle time is reduced. The primary moulding facility is a BMD dynamic automatic moulding line, manufactured in Germany by one of the world leaders in foundry technology. The production rate is up to 50 moulds per hour. Moulding sand, consisting of a special clay, water and sand, is squeezed into the moulding box containing the pattern. The sand instantly takes the shape of the pattern, which is then removed. White Industries also operate a series of jolt squeeze green sand moulding machines to cater for the smaller volume customer. This is a lower volume system that produces moulds for small ferrous and non-ferrous castings. This uses the same type of moulding sand as the BMD. Large castings are made using 3 high-intensity continuous flow mixers in 2 areas using 2-part chemically bonded sand. The sand sets, retaining the shape of the pattern when it's withdrawn. The moulds are painted to give a smooth surface finish. 6 induction furnaces are used to melt the various grades of ferrous and non-ferrous metals. The furnaces consist of a 40 kilogram unit for non-ferrous, a 150 kilogram unit and a 750 kilogram unit for specialty alloys, 2 2,000 kilogram and a 3,000 kilogram unit for irons and steels. The 3 larger furnaces have argon purging to improve the cleanliness of the steels. All melts have charges calculated from various ingredients to make the right grade of metal for each casting. Every melt is analysed on one of 2 optical emission spectrometers. The chemical composition is measured by rapidly solidifying a small sample and sparking it on the spectrometer. Elements measured include carbon, silicon, manganese, sulphur, phosphorus, nickel and chromium, to name but a few. The result is compared against the specification. If it is in spec, the metal is tapped out for pouring. If it is not in spec, additions are made and the melt retested before pouring. To maximise the reuse of low alloy steel runners and risers, a carbon boil is used to remove impurities such as sulphur and phosphorus. Oxygen is blown through a lance to create a reaction between the metal and the fluxing agents, which moves the impurities from the metal to the slag, creating a clean steel. Large castings are typically poured with a bottom pour ladle. The ladle has a special refractory nozzle in base, which is plugged with a refractory stopper. When the ladle is positioned over the mould, the operator uses the lever mechanism to raise the stopper. This allows the metal to flow in a controlled manner into the mould. Since slag is lighter than metal, the slag stays on the surface in the ladle and is prevented from entering the mould. When a casting is poured, extra feed metal is required to ensure it is sound. The feeders supply this extra metal and then need to be removed. Rather than oxy-cutting or cutting off with a grinder, the pneumatic hammer is used to knock the feeders off quickly and safely. Shot blasting removes any adhering moulding sand from the casting surface. It produces a smooth surface which aids in the fettling and inspection process. When a casting is poured, metal can leak into the joints between the mould and the core, creating flash. This flash and the stumps where the feeders have been removed are ground back to the required casting profile, as well as removing any sharp edges. Some customers require their product to be painted. This is done in the paint section. To manipulate the properties of the metal, especially alloy steels, various heat treatments can be used to achieve the customer requirements. The castings are heated to various temperatures up to 1100 degrees Celsius and either air-cooled or water-quenched. They are then tempered at lower temperatures to achieve the final properties such as strength and hardness. When the customer needs precision fits, castings are processed through the machine shop. Various vertical axis and horizontal axis CNC machining centres are used to bring the castings to the final critical dimensions, often with a tolerance of 0.02 millimetres. Turning, milling, boring and drilling can all be done with the equipment at WIP1 Industries. WIP1 Industries has a dedicated fabrication shop where the WIP1 brand of grain chaser buggies is manufactured. Laser-cut steel components are bent, shaped and welded to produce the buggies. Machine castings are used for the critical mechanisms to give a smooth-running, robust and cost-effective product that helps the farmer bring in the crop.